after it starts, we need to verify that it actually works.
Okay.
Yes, we are live.
Good. Hello, everyone, and welcome to this week's edition of the Jitsi Community Call. As you know, the past week we've launched support for bridge cascading. That's a pretty big cornerstone for us. It's something that we've wanted to do for a while. It's now something that's active on Meet Jitsi. People are using it. It's working really spectacularly well. And we're going to start this edition of the call with a brief tutorial from Boris on how bridge cascading works. So, Boris, take it away.
Hey guys, I hope that you can see my screen share. Can someone confirm, please?
Not yet.
Not yet.
Okay, so this is about cascading our media servers or Jitsi Video Bridge. And Octo is the name of the protocol that we came up with. So
I'm still not seeing the screen share.
Yeah, so see a black square. There we go. See it now.
Working now, yeah.
Maybe start from the top, Boris.
There's nothing really at the top. I was just explaining where the name comes from, or that it's the name.
I was just thinking that we can cut the recording and make it start from where you start. So.
Okay, so this presentation is about cascading our media servers, or our SFU called Jitsi Video Bridge, and we do this through a protocol that we named Octo. First, the problem that we're trying to solve. The usual way that people distribute video conferencing services geographically is that they deploy servers in a bunch of different places throughout the world. Then when a conference starts, initially they select one server, and that's where the conference is hosted. So one problem with this that we see happening in our system is, I'll just use an example here. And I'm using red dots to indicate servers and green dots for users. So a user from somewhere in Australia starts a conference. A server in Sydney is chosen. And then a bunch of people from the US join the conference. And the server is in Australia, and this is obviously inefficient. There are two problems with this. One problem is that the connection from the people from the US to Australia is probably not, is probably worse than their connection to a local server. So the round trip time between the participants in the US and the server in Australia is longer. The other problem is that the end-to-end connection from someone in the US to another one in the US goes through Australia, which is really inefficient. And that's what we're trying to solve with cascaded bridges. So in this example, what would happen if we were able to cascade bridges is we would select multiple bridges and have everyone connect to a local bridge. So this conference would instead be connected like this. There's going to be one server in the US and one server in Australia, and those two servers have to talk to each other and exchange the audio and video streams. And we do this through this protocol that we called Octo. So this solves those two problems that I described. If you look at two participants in the US, end-to-end. They have to go through the US server, but they don't have to go to Australia and back. And the other problem, the connection to the server itself is also quicker. So it's probably a better link. And most notably, the round trip time is shorter, which means that stream repair mechanisms such as retransmission, packet retransmissions can happen much more quickly. This is, in a nutshell, what bridge cascading does. And next, I'll go on to describe how we did it in our system. Oh, and just to generalize, we don't necessarily need just 2 servers. We can add more than 2, and the way we connect them is in a full mesh of servers. That's what we have right now. We have plans for other topologies that are going to scale even better than this. So our usual architecture uses shards. This is an example of a single shard. It has 1 instance of GCOFO, our signaling server, and 2 instances of our Jitsi Video Bridge media server. This is a set of 3 servers that live in this example, in the US East 1 region of Amazon. And this particular GCOFO instance can only choose between those 2 bridges. In order to allow cascading, we modified this so that the bridges from all of our shards connect to all GCOFO instances. This way, GCOFO just has access to a pool of Jitsi Video Bridge instances. The way that selecting a bridge for a specific participant works is the simplest possible. We look at the user's region. This is right now based on latency-based routing from Amazon's Route 53. But we are working on evaluating how well this works and potentially using another solution. So if GCOFO has a video bridge instance in the same region, it's going to use that. Otherwise, it's going to use one of the existing bridges in the conference based on load. And of course, if more than one bridge is available in this region, the selection is going to be based on load. So the least loaded bridge is going to be used. This selection logic and maintaining the Colibri sessions is all in GCOFO. So there is no signaling going between one bridge and another bridge. All the signaling is from GCOFO to a bridge. So we still have one central signaling server for the conference, and that controls all the bridges. And this is implemented as an extension of the Colibri protocol that we use to control Jitsi Video Bridge. On the media level, a single video bridge instance has a certain set of local participants. So these are clients connected to this bridge directly. I'm going to use the bridge on the left here as an example. So it has 2 local clients. And then it is connected via Octo to 2 more bridges, and each of them has 1 client connected to them. So on the Colibri protocol level, this looks like a single Octo channel that has 2 targets. One target is this top right bridge in Sydney, and the second target is this bottom right bridge in Europe. So this is purely for media. Uh, here is where the Octo protocol comes in. It's really a simple fixed header that we add to UDP packets, and I'll show the format in a minute. But it's a lightweight format with no state. So all the state needed comes from GCOFO to each bridge via signaling. So it supports RTP as well as a custom format for data channel messages. The way we do simulcast is simple. We just, for Octo, we forward all the streams to all bridges. So as far as the top right bridge is concerned, it sees a set of simulcast streams coming. It just so happens that they're not coming directly from a remote client, but they pass through a bridge. This means that the traffic between the bridges, that all the high quality streams are transported to all bridges, which might not be ideal, and it's something that we're going to be looking at in the future. For simulcast receivers, the logic is the same as it is today. So so this is the Octo header that we add to RTP packets and other UDP packets that we use for data channels, for example. It's a fixed size 8-byte header. Most notably, it has a conference ID, which identifies the conference. This allows us to have more than one Octo conference going on between two bridges. We have a couple of flags. Right now, we only use the M field, which specifies a media type, so whether this is audio, video, or a data channel message. So today we prepend this to UDP packets. In the future, we might turn this into an RTP header extension. One more thing about the security of the protocol. Right now, we guarantee on the network layer that communication between the bridges is secure. However, we realize that that might not always be possible, and even if it's possible, it's harder to do. Therefore, we'll be working on adding SRTP in some form so that we don't need to rely on a secure network between the bridges. So that's about it for Octo. Actually, one more thing. Some of these fields are designed with the idea to reduce signaling. So today, every bridge knows about all of the endpoints via signaling, which is not strictly necessary. If we add an endpoint identifier to the actual media packets, we can avoid that part of signaling. Same with simulcast layers. And that's something that we'll be working on in the future, reducing the signaling and moving more of this in band. So this is currently deployed on me Jitsi. We have 6 regions, 2 in Europe, 2 in the US, 2 in Asia Pacific. And you can see whether you're currently using this by scrolling over the little GSM bars in the conference. If you do it for your local thumbnail, you're going to see a server count. And if you click on show more, you're going to see the region where you're connected to. If you hover on the GSM bars on a remote participant, you're going to see the region that they're connected to. Right now on me, Jitsi, this is enabled as an A/B test with probability 50%. So you might not always see it work. We're going to release it in the next couple of weeks. Always on. And just as an example, in this conference, we have 16 people, and right now we have 4 servers. If I scroll around, I can find out where the servers are. I see US East, Europe Central, Asia Southeast, and there must be one more somewhere. So that's it. Thank you very much. And if you have any questions, let me know.
Thank you for the presentation, Boris. Let's restart the recording. There are other open solutions right now that do that. And as Boris mentioned, we're thinking of extending the use of the solution not only to, I mean, it already serves not only the purpose of geolocation, but one might use it for just serving higher numbers of conferences on a single bridge. So we're going to be working on adapting Meet on handling these cases better as well. So stay tuned for all this.
I just restarted the stream. However, I think YouTube is going to merge that, so we'll have to separate it. In post.
All right. You're right. They do that. Yeah, we'll separate it separately. I'm going to second Boris's request for questions. On Octo for now, and then we're going to proceed with the update if there aren't any. 10 more seconds.
Is there currently support for Octo via the REST interface?
I don't think there is. Adding it would be trivial. We just need to parse some of the fields and serialize some of the fields. But I think there's a few things that are missing right now.
Okay, thanks.
Okay, let's proceed with the update. Actually, that was the major release from us last week. We haven't decided yet. We have 2 more pending releases on Meet Jitsi. We have 3 recordings and live transcriptions. We might release one of them this week, or we might keep them for next week to allow a little bit of time for the Octo news to get its fair share of attention. In the meantime, we're working on various improvements on mobile, web. So we'll be updating you all as we move forward. I think that should be enough for an update. And we're now opening the floor for additional questions and requests for comments and discussions from anyone.
Can I ask something about the Android SDK for GC Meet?
Absolutely.
So that was I'm Radiant. So I'm just asking the question I have asked before, sort of follow up.
Go ahead.
So one of my custom requirement is that to have for audio only conferences to actually hide the UI. So that can happen on, we have our custom UI and we want to hide the Jitsi UI. And from what I looked at the moment, the Android SDK provides a Jitsi Meet view or Jitsi Meet activity, which is like it's like a wrapper for the React Native app. I'm guessing I need to try it out, but I'm guessing that maybe it would just work if I just hide it but run the activity in the background. Maybe it would just work with the audio. Not sure. That's one of my requirements, having like a headless mode for audio conferences. Whether that's doable with the Android SDK. The other thing is we would like to have an API for switching the camera without the user actually clicking in the UI button in a React Native app. But I think that is doable with some customization to the React Native, to the GCB view. Yeah.
So your question is, you're asking someone to confirm that?
Yeah, I just want to confirm that if my understanding is correct.
Zoli, Pavel?
Yes, so currently there is no way to control the UI through the API commands yet. If I'm not really sure, but yeah, probably it isn't. But it shouldn't be very hard to customize that. And about your question, whether hiding the view completely, would that work? I don't know. Maybe if you try, you'll see.
Yeah, I think I'm gonna try it. I want to try and see. Yeah, sure. Yeah.
So yeah, Saul has looked into that some, but he is not feeling well today, so he's not on the call. And Lubo, same thing. Maybe try it out, post on the forums, post on Discord, if it doesn't work. But yeah, it sounds like the avenue is not currently possible, but not really that hard to add these possibilities in the API.
Okay, cool. That's my question. Yeah.
Thank you for asking, Radium.
Hey guys, my name's Lewis, and I had a question regarding dynamic stun servers. So I noticed that the JVB now is using Ice4J for stun and turn, and there's a property where you can set it, the stun mapping harvester address property, but it looks like that property is only read in at startup time, at initialization. But if you're using a service like Twilio, for example, that requires you to renew your stun servers for security reasons every 24 hours, is there a way to do that without having to restart the JVB?
Yeah, it does actually have a stun mapping harvester, which is gonna act as a stun client. Does that make sense?
Well, I see the stun mapping harvester in the Ice4J repository, but it looks like initialize is only called when the JVB starts.
Oh yeah, you're right.
So if for example, Twilio, the longest you can have a stun server for stun server token for is 24 hours. If I needed to programmatically get a new token from them, I would need to reset the environment, the system property, and then restart the JVB, right? Would there be a way so I didn't have to do that?
Yes, I agree. That would be nice. That's currently not supported. It shouldn't be hard to add, though.
Okay. So
it would probably be good to see what the best way to do it would be. I agree it shouldn't be hard. One way would be to I guess the easy way would be to just add a reinitialize function at some point. Another way would be to make it reinitialize for every call, but that would add latency to channel creation and then call creation. And another way would be to just add some sort of an abstract API to actually getting that server and then delegating basically the updates to something else.
Yeah, or watching for system property changes on that value, right? And then that would trigger a reinitialize.
Yeah, which is basically a subcase. Let's just add an abstract method of obtaining a stun server, and we call that for every channel.
Right.
And then that abstract thing decides whether it uses the old one or whether it looks for a new one. Can you tell us how Twilio? Do they only change the token? Do they change the entire server?
So let me get the link. Actually, I can share it. They have an API to obtain a stun server token, and it has a minimum. Like it can the longest that it can be valid for is 24 hours.
And only the token becomes invalid after that.
Exactly. So then trying to do NAT traversal would fail. Let me get the doc so you can take a look. I will paste it into the chat here. That's kind of how they do it. And the longest that a token or a stun server credential is valid for is 24 hours.
So we only use the stun server once in the beginning.
Right.
And then we set the IP address and we advertise that for the rest of the lifetime of the bridge.
So actually, yeah, that's a good point. Luis, what do you expect from that stun server, actually?
So NAT traversal for pure
clients. Okay, good. It's good that Boris raised that. That's not what this stun server does. That one just lets you run the bridge on a NATed address, something like what Amazon does, for example.
Okay.
And we assume that NATed address doesn't ever change. So that one is just used from the bridge as a client so that it would find out its own address. If what you're looking for is for clients to obtain stun credentials, those are actually provided by Prosody. And they're queried on every session. Now, and updating I think that updating the token there, first of all, it doesn't actually require any meddling with the bridge. I don't know how simple it would be to change it while Prosody is still running. But I suspect whatever you need to do there would actually be easier because you'd just be able to write a few lines of Lua and that will get you sorted.
Gotcha. Okay, thank you.
Does that make sense?
Yeah, thank you.
Hey, this is White Kid. I've got a question here. We're relatively new to Jitsi. Very happy that we're moving to Jitsi. Question is around when the JVB detects per bandwidth, what exactly happens? Does the JVB pause the video and then leave it up to the client to detect the track mute change? Is the video track with a static gravitar sent down something else? We're trying to figure out. We're trying to figure out how to essentially replicate what the cool stuff that you guys have at meet.jitsi, which is when a user is on a bad bandwidth, the video automatically pauses or down reses, and then when the bandwidth goes back up, it up reses again. So yeah.
So the resolution changes are not signaled at all. When the bridge stops sending a particular stream, it sends a data channel message indicating the new set of streams that are being sent. That message, I don't remember the name, and it's something about last N. I can try and find the docs if you give me just a second.
while Boris is searching, I also want to answer that we never send avatars from the bridge. Those are actually filled in locally by the Jitsi Meet client. And so are the blurred video, the messages that say that for certain person, the quality is not there anymore. So those would have to be implemented. But the messages that Boris is currently looking for help you know that, look, we are not able to send you anything more here because we're not getting anything. So you better do something about the user experience. That part is in Jitsi Meet, the interpretation of these messages.
Yep, and I just pasted the link in the chat. It explains the format of the message.
Okay, cool.
Hi. Quick question. First, I want to give say thank you. Shout out to Damien. A few weeks ago, we had some issues running into this exception using Jitsi transcription, and that has now been resolved in our tests. We've not been able to replicate that exception. Sort of this clock started state problem. So thank you for all your help with that. We have just a kind of small follow-up. We're doing transcription, and sometimes in a scenario where we have multiple people in the same room, so we have audio that's getting picked up across everybody's microphones. We thought maybe the echo was like a configuration issue on, say the browsers. But now we're thinking that because we're using the mixed audio, they get saved to disk in Jitsi, and we're wondering if there's any advice on how we can better mix those different participant audio streams to avoid sort of an echo effect. I think what's happening as a result of those streams being mixed and having a very similar audio input, since some of the participants are in the same location, the microphone across those streams are all kind of getting the same thing, but there's somehow some difference in latency. So just curious if anybody's seen this before, and any other recommendation on maybe how to work around it if you want to use that audio.
I think this is a purely client thing. We've been thinking of a way of detecting like microphones in the same room or something like that, and basically doing automatic muting or something like that for the client. But I don't think there is much you can do on the server side with those streams.
Okay.
That's
yeah, we were
my
thinking
opinion.
Maybe, yeah. I mean, one thing we're thinking something similar is, if we didn't, I think the only risk with doing something on the client is if, we have a false positive and we inadvertently mute the signal, we may miss something valuable for transcription. So, if there's a way that we could use sort of the active speaker detection, sort of if we, instead of mixing the streams in real time, if we save the streams separately, then maybe we could mix them more intelligently using the data from active speaker detection to just, after the fact, keep only one signal if there are multiple signals from the same room. Does that sound like a viable solution? Has anybody tried something like that before? Or do you recommend just doing it at the client level?
If you want to play with recording streams separately, I can send you a branch that does this in a very ugly way, but it
I was
does
just
it.
curious what.
Okay, that would be really helpful. Thank you.
Sure, I'll find it in a second. But I'm a bit confused about how this occurs, because I expect that if this occurs in the mix in Jitsi, then you would have heard at least some feedback in the conference itself.
I think we're not, because people are manually muting their speakers out of necessity, or there'll be a lot of feedback.
I see.
And so you don't hear it till after the fact.
I see. Okay.
So, but yeah, it would be really helpful to, if there's any example of separating those streams and then, doing some sort of post-processing to pick only one, which is sort of the equivalent of muting all but one microphone, except I think there's less risk of losing data by accident.
Yeah, I only have the record separate streams hack in case that's helpful for testing, but it's not in a shape that can be committed.
I'm really sorry. I had to deal with something else here and I kind of zoned out. If you have a satisfactory response, then ignore. But if you're still looking for ideas, would you mind repeating the basics of your problem?
So the situation is we're using Jitsi transcription, and we have scenario where we have multiple people in the same room sometimes. And we're relying on not only the transcription, but the mixed audio file that gets written to disk. And I think we don't hear feedback. We solve feedback during the conference by muting all but one speaker if there are multiple
feedback
people in the same room.
as in you're just you're talking about just regular acoustic echo in order to avoid that.
Echo.
Okay.
Well, so we're not really, that's not a problem because we sort of manually address that. Although we are looking for a better long-term solution that does that automatically. So that's another, but I think that's a solvable problem.
So, but that's, just to be specific, what you're doing there is basically compensating for the cases where Chrome is not able to handle acoustic echo cancellation itself. So you just ask your users to mute. Is that what you're describing? Or?
Right, but the real issue we have though is even if we manually do that, the mixed audio, because if we say 5 people in the same room, the same conference, people talking is getting picked up almost identically on 5 separate microphones, and so when that audio gets mixed, seems to be slightly different latency across those streams, and so the mixed audio signal.
That's where I lost it. How come the same conference is picked up on 5 different microphones? Because those people are in the same room?
Yes, yeah. So often that happens in our scenario.
Oh, got it. Got it.
So they're in the same room, and so even if there's no feedback in the conference, there tends to be serious echo. Yeah.
Got it. Right. And then how does that tie into transcriptions?
Say again?
I was asking, how does that tie into transcriptions? Did this not go through again? Hello?
I can hear you now.
Okay, my question was, how does this tie into transcriptions? What's the problem with transcriptions there?
Well, so the transcriptions actually are working fine. We're just trying to use the audio, the mixed audio that Jitsi writes to disk. So ideally, in our scenario, we want to transcribe that all the audio from the conference, but also at the end be able to rely on for replayback, rely on that mixed audio file that gets written. But unfortunately, if there's if we have multiple people in the same room, that file has tons of echo. So we were thinking we can try to do some sort of echo cancellation after the fact, or probably the best solution is not mix them in real time in Jitsi, but write them separately, write each stream separately, and then try to mix them after the fact using some other input, such as active speaker detection.
Got it. So
yeah,
I would not advise you to do that with the separate recordings, because it would be just restitching everything back into a single file. While easier done for audio than it is for video, is still, I believe, a very substantial project. So unless you are prepared to put loads of work into that, I personally advise you not to go down that path. Now, I'm still a little bit confused because it sounds to me like there are 2 separate problems, but you're talking about them as if they're kind of related, and I think I might be confused. So one of them is multiple people in the same room and a single microphone, hence picking up a bunch of stuff that it's not supposed to pick up. That's one problem. And the other, I then do not understand how that has anything to do with mixing audio in Jigasi.
Yeah, I don't think. Yeah, that problem I don't think is really much of an issue. It's most of the scenario is where we have many microphones in the same room. Right?
Yes.
So
Okay, and that has nothing to do with mixing, right? So you're the completely separate problems, right?
Well, no, I think that is. I believe it's related to mixing because when we have those 5 streams, Jigasi will mix all the participant audio streams together and write a single mixed audio wave file. So when that wave file is written with all those mixed input sources, there seems to be echo, I believe, as a result of there being slightly different latency, but roughly the same signal on, say, 5 separate audio streams, but they're written to disk. Yeah.
So is this a conference? The thing? Are these people supposed to be able to hear each other during the call?
Yes, ideally.
So why is that not, like, if you have stuff coming in through the microphone even before you mix it, isn't that making the whole conference experience already completely unusable?
Yeah. So the way we've gotten around that for now is by muting. So if there's 2 people who are remote and then there's 5 people who are in the same room, which is a pretty common scenario, we'll just manually right now mute all but one all but one speaker in the same conference room. So that's why I think we're not. There's no feedback in real time as a result of manual muting. But if we didn't do that, yes, there would be crazy feedback. And so we're working at different.
You mute all but one speaker phone, as in speaker head. What's the word? Like just output, but you leave multiple microphones open.
Yes.
And having multiple microphones open, doesn't that make the conference unusable for the people who are not in that same physical room?
Probably, but we haven't really seen that. But yeah, I don't think so. Why would that cause a problem for the remote people?
Because
they would also get the
they would hear exactly the same thing that you're describing as a problem for transcription. So
that's true.
Like I would say, why would you only solve the problem for transcriptions while in the same time you have actual users on the call who are completely unable to, or a lot of suffering through these same consequences?
Yeah, that's a really good point. Okay, yeah, maybe you're right. So maybe we should really just solve this for the real time. So maybe the best solution then is to just rely on active speaker detection to only allow one microphone at a time.
So that's very hard. That's something that we're thinking about as a very long-term project at some point. And I know that other teams on the planet are looking into these same issues. It is very hard to do that automatically. What I can suggest at this point is a best practice, and you could maybe incorporate that in the UI or something, is to not only have a single set of speakers, but to make sure that absolutely every microphone is muted and people use push to talk. They just press on spacebar while they talk and they release it while they don't talk. I realize that's not a satisfactory technical decision. Another such non-technical decision would be, solution would be to just ask people to be in separate spaces, which is kind of a good practice in general for remote working. Because I just recently saw that report that when multiple people are in the same physical space, if more than one, they tend to get asymmetrical amount of time during the conference. Basically, they monopolize the conversation.
Sure.
But I realize that this is not what you were asking for. I'm just saying that technically solving that problem would be very hard, and your best chance, in my guess, and I might be missing something, but your best bet is to just circumvent it with a workaround with user interaction and basically ask them to change the behavior somehow. But yeah, I don't think it's solvable at all at the transcription level.
What part's not solvable? What do you mean by that?
If you get within the same, like this problem exists it's not the Jigasi mixing that introduces this problem, right? This is
It's the people in the same room.
right. That's what I wanted to say. And you would have a lot of trouble detecting, wait, but which microphone should I use for this transcription? Or should I do 5 different transcriptions and then compare and use the best one? How do I know which is the best one? Like, it just a ton of problems that have very difficult solutions. And really the problem isn't there. The problem is that you have 5 different microphones listening in the same room and that you have no way of like electing one that is somehow better than the other. So,
but even if we guess a little bit wrong, if it's not the perfect, isn't it still? It should still be a viable solution, though, right? Like, I mean, are you just saying the active speaker detection is not reliable enough, or are you saying that?
For that case, I'm pretty sure active speaker detection will not be reliable enough, and it would likely yield different winners for different parts of the same person speaking, even. And so the active, like, the existing active speaker detection today in Jitsi conferences is done on Jitsi Video Bridge. You would not be able to use it there. You would have to use it on Jigasi, which again would mean a non-trivial amount of code, even if you do it real time or if you do it while restitching conferences at the end. None of this would be doable within 2 or 3 months, is what I'm saying. So you're looking at a very, very prolonged project for questionable results. Again, feel free to ignore what I'm saying because I don't know all of your constraints. It's just my initial feel to this.
Okay. Well,
sorry, I can be more helpful.
No, I appreciate it. It is really helpful. So we'll keep investigating it, and then we'll share what we come up with at the next call.
So we actually, just something more. Boris actually had looked into this adventurous mutual mute project a few years ago, which was supposed to help with these cases. And it was to a large extent working with the user to identify these situations.
What's the status of that project?
It was just an experiment. I don't know if any part of it is public, actually, Boris.
I don't think we got that merged, but the extent to which it went was to add a button in the UI that you click, and it only automatically did the muting the speakers that you have. So it didn't address the problem that you described. Only half of it. Yes. Although, now that I think about it, we could play with this together with active speaker detection on the bridge. And
yeah.
But I think you tried that back then. You didn't pick up any signal that would let you...
Yes, the hard part is automatically detecting that 2 microphones are in the same room. But if we can live with user interaction, we might improve upon that. So if the bridge knows that 2 endpoints are in the same room, it can only keep one of them unmuted based on that speaker detection.
That should be really viable. I mean, because there are definitely, we've thought of a lot of strategies to be able to detect that. Like, we could even use Bluetooth or even manual explicit input, so that.
Well, can I ask you something? Why is it that you leave multiple microphones unmuted in the same room? What's the purpose of that? This is not a leading question. I'd like to understand.
Well, in the case of transcription, more input sources, the better, right? We ideally want. We can't always rely on like a specialized hardware device, and so in the situation where we want the absolute best audio, so the closest mic to a person, especially given transcription, we need the best signal possible. That's the rationale behind it, because we really want to maximize the accuracy of transcription.
So that does mean that you do want to have the best source detected automatically, then.
Yeah. Exactly.
Well. Yeah.
Solving this would be really valuable.
It will be really valuable. It's like, don't get me wrong, I don't disagree with that part. I'm a very, very, very hard problem to solve in a way that actually contributes significantly to a better experience. And you already have some user training apparently where you just tell your users to mute their speakers. So I would, compared to that, asking people to do push to talk sounds like a very, you know, like a much easier and not necessarily worse way of doing things.
Well, realistically, we have to solve the speaker as well. I mean, long term.
Okay.
For initial testing, it's fine, but for long term, we need to solve both problems.
Well, I very sincerely wish you good luck. I hope that we'd absolutely be interested in following and helping with that work in these calls, but just be prepared that it's extremely, extremely hard.
Okay.
Like, and to give you an idea of what I mean, echo cancellation itself, where both the output and the input are on the same device, is extremely hard. And even small, minuscule amounts of clock drift because of use of different devices, for example, are enough to spoil that, and have been spoiling that for years. What we're talking about here is different users on completely different devices sending streams that are not even being analyzed on these same machines, but actually go through latency, network latency, and all of that. Yeah, I just as an indication of how hard that would be. Now, if you're only interested in the transcription part, fine, but then you still have to solve the problem for those other two users that are listening to 10 different streams the same way. So,
but it does seem simpler than the echo cancellation, just because the worst, if we guess wrong, the worst case scenario is we just get a slightly worse. We don't get the best input source. Right, like, so as long as we can reliably detect when people are in the same room.
That's a good point.
Right, so like, it doesn't seem too terrible. I think doing it perfectly is very, very hard. But to do it reasonably perfectly, we just might end up with a less than ideal input source, right? But that's still better than echo.
Yes, but that's not. I agree, but that's not your comparison, right? Because the whole reason why you have multiple microphones is because you want to have the best input source.
Sure.
And so I guess it's about how much time do you guess correctly, and is it better than just having a single microphone in the room, I suppose.
Right. Right. And that's what we'll have.
But yeah, extremely interesting project. So thank you for sharing, and really best of luck with this.
Thank you. Yeah, and if there's anything from Boris's project with the muting speaker, because I think I'd read about that. If there's anything that can be shared, that would be really, really helpful. I'd be happy to kind of build on that if that's something that can be shared.
Let me dig around.
Okay, great. Thank you.
All right, then I guess 10 more seconds for other questions. Well, thank you everyone for joining a very interesting call, and see you all again in 2 weeks. Bye-bye.
Link posted in the chat room.
Thank you. Bye, everybody. Thank you.